Hello friends, welcome back to Light Tutorials. So today in this video we'll learn the Matlab code for Dsbsc modulation. Okay, in my analog communication tutorial I have explained your Dsbsc modulation. Now we'll see it in the Matlab code form. Okay, so for Dsbsc signal, what are the general things we need? Okay, that means we need a carrier, we need a message signal, and if I multiply this both, if I multiply this both and then I'll pass it to this thing to the low pass filter. I'm sorry, it is a modulation, right? I'll pass it to the band pass filter. Then I'll get what? Modulated signal. Modulated signal, or this is my DSBSC signal, right? Now this DSBSC signal I'll send it to the low pass filter. Thereby the original message signal I'll get. So this is called demodulated signal. Demodulated signal, right? Now if if I take if I take the FFT of this, let us say, to get into the frequency domain, I'll take FFT of carrier signal, similarly FFT of message signal, FFT of modulated signal, and also if you want, you can take FFT of demodulated signal for getting the frequency spectrum. Okay, what is the bandwidth? It is 2 times of highest, 2 times of what? Highest message bandwidth, highest frequency in the message signal. Okay, this is also represented as 2W. Okay, it utilizes 66.7% of the power. Right, now let us see the MATLAB code for this. So here is the thing, I have defined the time instant here from minus 0.0 to 0 with a time gap of 10 per minus 4, that means 10 milliseconds. Okay, similarly I've defined other time, and I've defined a constant TA here. This is just these parameters are for getting the message signal. Okay, because message signal generally it will be if we take here triangular type of signal. Okay, sawtooth waveform, anything you can take. Okay, I've taken triangular type of signal, so I've added padded zeros to it for first to 1 to 200 and also for 1 to 400. Okay, similarly I have taken other message signal from backward. It is I added 1 to 400 zeros, and in between my M2 and 1 to 200 zeros again. When I subtracted M1 from M2, I'll get my message signal. Okay, now I've defined the time instant for carrier signal here. It is from minus 0.04 to 0.4 with a gap of 10 milliseconds again. This is my FC is my frequency of carrier signal. Okay, cos 2 pi FCT. This is my carrier signal. Okay, this is my carrier. Similarly, this is my DSBSC signal. Okay, 2 into cos 2 pi FCT into the message signal, whatever message signal it is, that is. This is my demodulated signal. So for demodulated signal, what I need to do? Just multiply it with the product modulator. You multiply it with the carrier signal. Then you'll get your demodulated signal. So here I have defined the filter with what is a window here with A starting at FIR 1 25 comma 100 into 10 power minus 4. Similarly up to 1. Okay, these are the limits of the filter band for the demodulation. Then similarly, these are the limits for forming the Fourier transform. Okay, here frequency response of the message signal. These are the carrier signals, and this is for DSBS. This is for message record message signal. Everything is defined in the top here. For everything, you have the information here. Okay. After that, just plotting it with respect to the respected domains. Okay, the message signal, DSBS, demodulated, recovered, and their frequency responses. Okay. Now let us run it, save it and run it. Now see here, first this thing. This is in time domain. All are in time domains. Okay. This is my message signal. Okay. And here is my DSBSC modulated signal. This is my demodulated signal. Okay. After filtering, I'll get the recovered signal like this. You can see here, just there is a small aliasing here. From if you compare this and this, just a small time gap or else aliasing. This is due to the noise present in the receiver. Okay. Now this is the modulated in time spectrum in time domain. Now it is in the frequency domain. FFT of the message signal like this. It is a sync type of signal. Okay. Here are the two syncs here. This one sync, this one. This is your impulse responses. Okay. If you Fourier transform, it gives the impulse, right? Whenever it is a carrier signal, cos 2 pi of ct, right? So when you apply the Fourier transform, you get del functions. Similarly, the case with the message signal. Message signal was a triangular type of signal, so the response is different, little bit different. Now this is the DSBSC response. So DSBSC response is also same. It gives you impulses, two impulses. At it is double sideband, suppress the carrier. So we suppress the carrier, we get only message signal amplitudes here. See, this is one double sideband we have. Okay, and the recovered signal is same as the message signal. Okay, so this is how we perform the DSBSC signal in the MATLAB. Okay, that's all for this video. Thank you. If you like it, you share it and subscribe it to my channel. Thank you.